Okay, we're gonna discuss the fixed bias configuration in AC analysis. No, we've shown that you've watched the videos, no, sa RE model as well as the introduction of the BGT AC analysis. So, i-assume na ako na tan-aw to ninyo, and this will be the first topic of the AC analysis of fixed bias configuration. So in our electronics 1, as you can see, fixed bias is composed of two resistors, no, with the supply RB, RC, and BCC. So a quick introduction, no. So in BGT AC analysis, there are four important parameters to consider. So the input impedance, the output impedance, the voltage gain, and the current gain. But in this new edition of the book, no, the current gain, iwala niya ang current gain, but ang three na lang nabilin, no, the input impedance ZI, no, input impedance, the output impedance, and the E sub V, known as voltage. Input impedance, output impedance, or voltage gain. So in order to calculate these three parameters, we need to follow the three steps, no, para ma-analyze ning fixed bias configuration. So the first step, in order to analyze the configuration in AC analysis, is to ground all DC sources. So ground ni VCC, and tumura mo siya i-ground, no? So ito i-ground. So if you ground VCC, inana yung tsura, no? So yung transistor. So if mag-ground yung BCC, so as you can see, RB mag-ground, and also ang RC mag-ground. Ayun, RB as well as kani ang RC is loop. RC mag-ground, ayun ang RB ground siya. RB siya kay RC. So this will be now your B out, and then BI. This is your input impedance ZI. Try mo ang output impedance Z out. So nag-ground na siya. After that, apply the RE model. Kanina yung model, no. So apply mo siya. Apply na yung RE model. Butan mo dali. So kanina yung transistor. So this is the AC equivalent or RE model for BGT transistor. So kani muna puli dali. ZI. So apply beta RE, ayun, beta IB, RC. So this is RB, this is beta RE, RC, this is BI, input impedance, this is the output, BI, no, it's II, IB. So if it is small letter, meaning that is in AC analysis, no, gamay nga IB, gamay nga II, and also ano siya, no. So we have now the RE model of a fixed bias Muna ang array model sa fixed bias of a fixed bias configuration. Now you have now RB, beta RA, then this is beta IB, and then this is RC. So if you have now the RA model, so napadinabilin di usa. So napay RO diri. RO. This is RO. So just redraw na lang. Gubot. So RB, we have beta RE, we have beta IB, RC, RO. No? This is ZI, VI, I out. This is the array model. So in the array model, nani si R sub O, but if R sub O is 1, is a larger value, usually kiniglit ni araw, basta dako kayo. So we have now the array model. We can now calculate the three parameters, no? Input impedance, the output impedance, and the voltage gain. So let's start with the ZI, input impedance. So as you can see, ang input impedance is taken from the input side, no? So kung yung tanawon, the input impedance is just equal to parallel na siya sa RB beta RE, no? It's just parallel RB and beta RE. So you have now input impedance equal to R parallel beta RE. How about the output? Output is the same, no? RC parallel R sub O. Or if RO is greater than or equal to 10 times RC, pwede rin mo RZO is equal to RC. Approximate ba? Approximate. So you have na formula kani output impedance. So if RO is greater than 10 times RC, Z out is just equal to RC. So how about the voltage gain? Sa aming pag-solve. So in the voltage gain, if you look at in the output side, no, V out, so namani IB man ni, beta IB man ni nga current dere. That is beta IB, no? Beta IB is just equal to IC. IC ni. Is IC. No? So, meaning, current sa RC ug RO, ang kung imong i-add, equal sa beta IB. So, therefore, V out is equal to, so since the direction is pabalik, negative beta IB times this is the current plus total resistance RC RO, no? So as we all know that the voltage gain is just equal to VO over VI. Voltage gain man, ratio between V out over VI. So dapat makakam up tag inani, no? And then in the input side, no, kani lumani ang IB. So this is the IB current. IB man siya. So base man siya nga terminal. So therefore kaning current is IB. So kung imong kuhaan ang input VI is equal to is just equal to kaninga current and then the resistance. So IB beta RE, no? So IB is equal to VI over beta RE. So substitute nimo na dala. No. VI is equal to IB beta RE, and then IB is equal to VI over beta RE. Substitute na to dali. So therefore V out is equal to negative beta times VI over beta RE times RC parallel siya sa RO. So cancel ni. So V out is equal to VI over RE RC parallel sa RO. So since the voltage gain is the ratio between V over VI, so therefore AB V over VI, no, is equal to RC parallel RO divided by RE. Ano formula, no? So voltage gain is equal to RC parallel RO divided by RE. So don't forget the negative na eh. Or if RO is greater than 10 times RC, pwede mo gamit ang voltage gain is equal to negative RC over RE. So you have now the input impedance, output, and then the voltage gain. So let's have an example. So by the way, if negative na sign, what does it mean? If you have a signal dari, signal, no? So yung phase ana siya. Yung output niya, so since this is an amplifier, so meaning yung output niya is, so from a very small signal, yung padakon dari. But since this is negative, bali yung signal ng ihatag. Instead ng inani, sumabali siya, but larger. So, depende sa magnitude niya yung ihatag. So, negative means 180 degrees out of phase. Out of phase. Ano pasabot sa negative, no? You have a very small signal. So you have an amplifier. So this is now an amplifier mo siya. Yan, padak on. No? So this is a basic ni siya nga amplification sa signal, which will be maghimo tag amplifier in a final project. Dayan. So let's have an example. We have 470K, RB, RC, K3K. Ayan, 12 volts ang yung BCC. Find R sub E, ZI, ZO, and ZI and ZO with RO is equal to infinity. So meaning pwede na nato i-neglect ang RO. Taman sa D, but ang E, repeat na to ang C o D, but ang RO is equal to 50K. No? Tanaw na to. Na ba siya difference? So, RE. So, remember your electronics 1. Diba, ang equivalent circuit sa transistor is na may diode siya o a current source, no? Ang diode na may equivalent circuit, ang equivalent resistance sa diode, which is equal to R sub E, no? Which was discussed sa RE model na video na YouTube. So meaning na dito ang explanation where ang RE is just equal to RE is 26 millivolts divided by I sub E. No? Formula. We need to find IE sa para sa since this is capital, so meaning DC analysis atong buhaton na ni. So ang IE is na adere. Oh. So pare-pareha naman ang value sa IC ug RE. So kuan sa nato ang AB itong pala sa electron sa kuan ba. So we use nato nga ginabuhat. So, in order to calculate IE, kuan sa nato si IB by KBL. So, KBL at base emitter loop. So, 12 volts minus IB is 470K minus 0.7 equal to 0. So, therefore, IB is equal to, balance because 12 minus 0.7 is 470K. So, IB is calculate. Kailan na? 12 minus 0.7 divide. It's nasa 24.04 microampere. So, remember sa imong previous ng discussion where ang formula sa IE is equal to beta plus 1 IB, no? Ano yung formula? So, IE is equal to beta not is 101 times 24.04. So, IE is equal to 101 times 2 milliampere. Kaya E, so masolve na mo ang R sub E 26 millivolts divided by 2.43 milliamps. So R sub E is 10.7 ohms. 10.7. So just memorize this formula, no? Kani R sub E 26 millivolts divide IE, and then kani sa atong previous discussion ni siya, so ibalik na siya, memorize. Continue ta. So you have now R sub E and GI na po. GI is the formula. GI is RB beta RE. So GI is RB is 470K. Parallel siya sa 100 times 10.7. So GI is diretso kalkyo. Jadi parallel ana 1 over plus times 9.7. So that is 1067.57 ohms, no? Ano siya ZI. Next, C, letter C. G out is, so R out is infinity, so RC parallel R2, so since ang R is infinity, so it's just equal to ZO is equal to RC, which is ang ZO na to is equal to 3 kilo ohms. So yun na kayo. Voltage gain AB is equal to negative RC over RE So kani 3K ay kalimot sa negative pa 10.7. So this is 280. So that's negative 280.37. So mo na yang this is our voltage gain, no? So what does it mean? Ano pa day? Letter E. So ni E, B, C, D din eh. Letter E. So letter E, balik data sa C and D, but we're gonna use 50K. So balik to sa letter C. So this is Z out is equal to RC parallel RO. So this is 3K parallel siya sa 50K. Ilang na? So 0.83 kilo ohms, no? Letter D. We have now voltage gain is equal to negative RC parallel RO divide RA. So this is 3K 50K divide 10.7 ohms. So negative 2.83 divided by 7. Na negative 264.49. So i-compare na to nindo ha. Without RO, ako na to 3K and negative 280.37. Then with RO 2.83K, then mo yung voltage gain. So in the specification na yun yung RO, di yun mawala. But in order to minimize our computation and mga hand calculations ng mga solving, we're gonna use approximate method. So mangita tag pamagi para ma-approximate. As you can see, if you don't include the RO, which is applicable only if the RO is a large number, gamay ra sa diferensya, no? 2.83 and 3K, very very close if ang imo RO has a large number or equal to infinite. The same way the voltage gain, gamay ra sa diferensya, no? It's either you omit the R sub O or you include the RO. So either way, no, both are correct, but the most exact answer ani is kani, because we've considered the value of RO in this situation. Battery atong siyang i-assume as infinite, no? It depends on the problem. So the reason why Boylestad na author of the book, no, gamit siya approximate analysis, kita asking solution if i-mo na i-include yung R sub O sa tanan nga problem. So that's why nag-introduce siya approximate analysis as well as the exact analysis. But depende sa problem, no, it's either na IRO or wala, but they have close ra ilang answer. So let's talk about this negative, no, and what is voltage gain. Yung voltage gain, so if you have an amplifier ni, so say fixed bias, ato lang box fixed bias amplifier. So you have the output, this is the input. So if you have in input nga buta na to 1 millivolt AC, no, Ang tama yung output if your gain is about, let's use 280. So nakay voltage gain niya negative 280 37. If you have a microphone, microphone, no? So tagatingog di mo matag siya balig 1 millivolt nga voltage, or sometimes micro gali na microvolts, very small voltage. So that's why we need an amplifier para mudako ang kaning nga voltage, no? So if you have voltage gain, sa ito formula sa voltage gain, VO over VI. So para makuha na tong VO, multiply na to ang input, which is 1 negative, no, times 280.37. So natay point, natay 280 negative millivolts, no? Nakay magawas diri na out of phase siya na negative, wala na, di na siya negative 280 millivolts. So from a 1 millivolt voltage, ninggawas siya sa amplifier as 280 millivolts, no? Pwede na din siya nimo i-fed sa speakers, no? So imagine you have a microphone, no? So ang gawas niya is 1 millivolt. Imo siya i-direct sa speaker. Matingog ba ng speaker? Iba dili X. That's why you need an amplifier in order to amplify this very small voltage into a very large voltage, no? So muna gamit sa amplifier. Ito tingog ng speaker. So in order to drive the speakers, which is required siya mga larger voltage para matingog. Ano na siya?